This is 7.6, day 1, part 2. We've just graphed the inverse function for the natural log of x on this previous slide in the red. So if we talk about graphing ln of x minus 2, remember those transformations that we learned at the beginning of the school year? When it's inside the function, we have to think opposite. So it's going to shift it to the right 2 units. So if we look at these ordered pairs in the red, 1, 0, 2.71, 7.32, 1, 0, 2.71, 1, 7.32. If we move those ordered pairs to the right, so if I just graph the original f of x equals ln of x like we did on the previous slide, quick sketch. If we take those ordered pairs and shift them to the right, 2 units. Here's this one, and that one. So it looks like that. You can also just add 2 to each of your x values and complete this chart. All right, let's go on to evaluating the functions with the calculator. So we want let x equal 2. So this is our function. It's the natural log function. Remember, that's base e. With your calculator, make sure you know how to do this. F of 2 is saying, what is the natural log of 2? Well, that is 0.69. And then another example, the natural log of 1/2 with your calculator is negative 0.69. Go ahead and pause if you need more time. And then notice this last one. Let x equals negative 1. When you substitute a negative into the function, what happens is it's undefined. You can't have a negative value for x with a logarithm. The reason why is if we go back to this slide, the red function, notice its asymptote is the green vertical line. Anything to the left that is a negative value. You can't have a negative x. So the domain for this has to be greater than 0. In this case, our domain was less than 0, so it wouldn't work. So we call this undefined. All right, very important properties for you to write down. We've already done the ones on the left. We've written this one down, the inverse property and the inverse property. Here are the inverse properties now with logarithms and exponentials in base e. So we have, this is a new property, write it down. E raised to the ln of x. They are inverses of each other, so you're left with x. Or e raised to the log base e of x. It also equals x. The next property, the natural log of e to the x and log base e to the x, cancel each other out, they're inverses, so you're left with just x. And then our last two, the natural log of 1 equals 0, and the natural log of e equals 1. Go ahead and pause if you need more time. All right, now we're going to go ahead and use those properties to simplify. So the first example, e raised to the natural log of 6. And we want to find out what is the simplified form of this expression using the properties. So e raised to the ln of 6. Well, that's this property right here. E raised to the ln of x. You're just left with this 6. So this is your answer. So then example 2, I'd say you don't need to write down. Same thing. E raised to the natural log of 2, they're inverses of each other. So you're left with just 2. Now you're not able to do that yet with example C here. The reason why is there's a number 4. But I've learned earlier in the chapter that I can bring that 4 up. So it can be rewritten as e raised to the natural log of 2, and then that 4 now becomes a power. Numbers in front of a logarithm can be brought up as a power. Now the inverse property exists. E and ln will cancel out. Now I'm left with 2 to the 4th. And then I can solve what 2 to the 4th is. 2 to the 4th represents 2 times 2 times 2 times 2, which is 16. Here is your assignment for 7.6 day 1.